Hi, my name is Tzuriel Lampner and I'm from PACS R&D, and today I'm going to talk about oncology reading. And so for this I've loaded a study on the PET-CT application of a patient who had a lump in her elbow, and she came for a test, and it actually found out that she had a non-Hodgkin lymphoma. So the patient has 3 priors and a current study, and during oncology reading, most of the time what we'd like to do is to do 2 things. We'd like to track new lesions, to find them, and we'd like to track lesions over time to see their progression. So here we have a PET-CT study, and on the left you can see a MIP image of the PET, you can see a PET image, you can see a CT image, and you can see a fuse image, which is a superimposed PET over the CT image. The PET is drawn there in hot iron, which is a red, yellow colors. So each row represents a different study. We have a current study and we have the prior studies. And as you can see, the lymphoma, you can see over the MIP images that the lymphoma is pretty dark there. And most of the times when we're talking about oncology, we'd like to use lesion management tools. And lesion management tools actually work okay for CT and for MR, but we added a new tool to handle PET and SPECT images as well. So once talking about detecting new lesions, the lesion is only evident on the PET imaging and not on the CT, so we have to use some kind of a tool to detect them, to segment them over the PET images. So this is what we've done here, is we've marked 2 segmentations, 2 threshold segmentations over the PET images, and we are tracking them over time to see what's the progression of the disease. So as you can see here, you can see a lesion which was marked with a sphere. What we're talking about is the whole radiology workflow separates between quantitative and qualitative. So some customers, some sites use qualitative measuring, qualitative impression of the study, so like saying this looks like it's better or worse, and sometimes they use actual numbers. So this study uses a technique which actually measure inside the PET study and gives us SUV values. SUV values are standardized uptake values of the PET, and it will quantify the lesion over the PET. So if we can do the same quantification over each of the PET, we can see a trend of the progression of the disease. So this is exactly what we did here. The radiologist already marked a segmentation over the most old prior, and he did it once again over the prior 2 here, and once again over prior 1. And what we'd like to do is to measure it over the current study. So we can do it with a lesion tracking tool. We can do it manually. Here I'm going to use a lesion tracking tool, and it's as simple as clicking on the prior study and then on the current study, and the system will automatically detect, segments, and follow up together these lesions. And as you can see, it automatically segmented here a lesion, which we can see here. Let's see. We can see the SUV max went down to 1.9. Okay, so on the oldest study, it was SUV max of 41, then 14.1, then 16, and then down to 1.9, which is the disease is becoming better. Okay, so what we did is we segmented over the current study, and now what I want to do is I want to show the bookmark list for this patient. So as we can see here, we have a new 3 lesions in the study. One is a lymph node, and the others are threshold segmentation tools. And you can see here the SUV values. We have the SUV max value here. And you can see, for example, let's go directly into follow-up layout, and that now we can see that the lymph node, the threshold segmentations you can see the progression of, see here the SUV max went down from 46 to 3.2 and from 41 to 1.9, which suggests that the disease is getting better. And what I like to do is to open the report here. And opening the report shows me recessed diameters over these lesions. And I also get the SUV max, as you can see here, from the baseline study, 46 down to 3.2, and the other lesion SUV max went from 41 to 1.9. This all, since it's a preliminary report, this all can be embedded directly into our native reporting. And what I can do is just copy analysis, copy these measurements directly into our report. I'll add key images, and this will minimize the risk of any error within this process, directly taking all the measurements into our report. So I'll do it now. Okay, so I've opened my report, and basically what I like to say is that any progression was evident, but what I'll show you is that using the copy analysis, we can just manually insert the measurements directly into our native reporting. Copy analysis, copy key images, and this is how easy it is to embed all my analysis of the study, all my measurements of the study within the report. And the analysis went into our report, and of course the key images as well. So this is basically the workflow for an oncology reading. We have to segment new lesions, we have to detect new lesions, we have to segment or track lesions that we already saw, and we go directly to the report from there. Okay, so what we did is that we used a PET-CT, which is the home of the oncology reading. We did some segmentation using the new threshold segmentation tool in order to segment lesions over the PET imaging, and we used it in order to track the lesion over time and directly embedding it into the report. Thank you.